Ahí está la altura del chorro. Lo que sucede el chorro no puedo ver bien porque tengo el cañito del surfactante. Pero bueno, ahí estamos viendo más o menos lo que sucede en el chorro. Arriba no hay rosado, así que lo que está subiendo es lo que hay abajo. Simplemente, miren cómo subió ahí, qué hermoso cómo subió. No entiendo bien lo que está sucediendo. Bueno, sí, esto está flujo estacionario. Miren cómo suben ahí sola, miren cómo suben, increíble. Esto es hermoso, está precioso.
Hey everyone, today I'm going to be showing you a crazy awesome little known phenomenon where things can actually flow upstream against the flow of water. So I have this can of clean water here with a spout on it, and then I have this measuring cup that's contaminated. So let's say I wanted to add this water to the contaminated cup. So I start to pour the water like this. Well, how nervous should I be that I'm actually going to get some of the contaminant in my jar if I'm just pouring it above it like this? Well, most likely you'd say that you don't really have to be worried about it, especially if there's no splashing. If you get a splash that jumps up into here, obviously it's going to contaminate your clean water. But what if you're just barely softly pouring it into there like this? Do you have to be worried that some of your contaminants are going to go upstream, up the spout into your can here? Well, most likely you'd say no, and that would seem right in most cases. But it turns out there's a really weird phenomenon that's actually not very well understood called upstream contamination. And in that case, particles can actually travel up the stream of the flow of water and contaminate the source. This phenomenon of upstream contamination was first discovered by an Argentinian physics student when he was preparing his drink of mate. You can see that mate is made of these little tiny leaves here. What he noticed was that when he was adding water to his mixture, without the spout going in the water, he noticed that some of those mate leaves actually made it up into the container of fresh water he was adding. If you know anything about fluid dynamics, you should know that besides the edges where the water is touching, the velocity should be flowing downward. So when you're pouring the spout, the water's flowing downward, so all of the velocity components should be flowing downward as well. There shouldn't be anything that could push it upward. So it's a weird thing to notice that a particle could make it from down below up back into the container if all of the fluid velocities were flowing downward. So let me show you how to recreate this effect, and then I'll explain the physics behind it and how it's actually happening. How can something flow upstream? So I'm going to be pouring water into it with my homemade spout here. I made it a little bit wider and I painted it white so you could see it. And I'm going to be pouring it in from the side here, about 1 centimeter above it. And then I'm just pouring it in this container here because it has this outlet that's a little bit below the top level here, so I can continually flow it and wait for the phenomenon to occur without losing all my leaves on top. So first let's put our mate leaves in some water. So this is just room temperature water, and I'm just going to be pouring from my homemade spout here, and I have my sink connected to it so I get a continuous flow. Okay, let's pour this and see what happens. Whoa, look at that. A mate leaf shot up into it. Let's see that in slow motion now. So you can clearly see that the mate is below the level of water, so it's not like we have the spout in the water. There's at least 1 centimeter clearance there, and you can see that one mate leaf just somehow makes it up into the spout. Besides mate leaves, this also works with chalk particles. It actually works even better with chalk particles because they're a little smaller and they flow a little bit better. So you can see that as I pour the water in here, you can actually see a lot of the particles easily make it up into the spout. Now this is amazing. My water is clearly above the surface here. So somehow these particles are making it from this contaminated water up into my clean water spout, even though the main flow of velocity is downward away from the spout. Now, if you don't think this is weird, you should. And it's actually a little scary because most of the applications in which we're pouring fluid, we usually are pouring something clean into something dirty. And we count on the fact that that dirty thing isn't going to flow upstream into our clean thing. But what I'm telling you here is that in some cases it can occur. Now the physics student that first discovered this, he told his professor about it, and they actually did a few other experiments with it, and they discovered that it didn't matter the temperature difference, so it wasn't some temperature phenomenon pushing the particles up into the flowing water. They were doing it at room temperature, and this experiment I just did was at room temperature as well. But they did allude to the fact that it probably has something to do with the Marangoni effect. Now the Marangoni effect can cause flow to happen when there's differences in surface tension of two liquids. I showed this in a previous video when I showed that you could get a liquid to solve a maze using the Marangoni effect. For example, if you have water and alcohol next to each other, it will actually cause flow to happen between the two. The alcohol has a lower surface tension than the water, and so it wants to spread out more, and the water wants to recoil away from it. And so if you actually put particles in there, you'll see flow happen. You can see the dyes start mixing here, and you can actually see if I put a little styrofoam ball on top of it, you can see it flow from the low surface tension to the high surface tension. That's because the higher surface tension water wants to pull particles more than the lower surface tension. So there's uneven force on both sides of that styrofoam sphere there, and the water pulls it more than the alcohol does. So it actually creates a flow, it pulls it towards the water. So how does this apply to making particles move upstream here? Well, what's interesting is these researchers actually measured the surface tension when you put particles floating on top of water. And what happens is it actually lowers the surface tension. So basically, the more mass per surface area that you have on top of water, the lower surface tension it is. So what that means is that when I'm flowing clean water onto a surface of water that has floating particles on it, those floating particles are in a liquid that has a lower surface tension now. So if I get the water going into it close enough, even though the water is flowing fast and the velocity is moving downward away from the source, what happens is the Marangoni effect, due to the surface tension, the high surface tension of the clean water and the low surface tension of the contaminated water, the Marangoni effect causes those particles to be pulled up into the higher surface tension water. It's weird, it's almost like there's this skin on the water, and you can see those particles just get sucked up into the skin of it, and they just kind of sit there. Even though the water's flowing below it, these particles are just kind of on top of it, hanging out there. And sometimes they can just get sucked right into the stream. So what's happening here is probably the Marangoni effect pushing particles in low surface tension to higher surface tension. Even though the bulk velocity of liquid below the surface is moving downward, the surface actually pulls them upward. So it's almost like this skin over the water can pull particles up into it, contaminating the source. Now what's good about this is it happens more at shorter distances. So the closer your spout is to the surface of the water, the more likely it is to suck up particles into it. So if you're really worried about contamination, don't pour something really low to the surface of it. Now this video really blew my mind. Somebody messaged me about this thing called upstream contamination, and I had actually never heard of it. And I didn't think it was a real thing until I read about it and then read the research on it and then tried it myself, and sure enough, it is a real thing that's out there. And thanks for watching another episode of the Action Lab. I hope you enjoyed it. I hope you learned something. If you did, don't forget to subscribe if you haven't yet. If you have any questions or comments, let me know in the comments section and I'll try to get to them. And check out theactionlab.com to see the Action Lab experiment boxes. And thanks for watching, and I'll see you next time.